So I'm going to go through problem 6.17 from homework 3 for ME 111 System Dynamics. So in this problem here for your homework, they asked you to obtain the model of the currents I1, I2, and the voltage V3 given the input voltages of V1 and V2 for the circuit shown down here. So there is your input voltages V1 and V2 that they reference right here, and they want you to find this I1, I2, and the V3 right here. So the first thing that I do once I've read through the problem statement, understood what are the givens, what they're asking us to solve for, I redraw out my diagram here, and yes, it's provided right before us, but it's nice to redraw it out by hand to kind of get a feel of exactly what's involved. Okay, we have a voltage source here, we have a resistor there, the current, you have an inductor here, there's your V3, there's the L2 there, your I2, over here is our other input voltage V3, here's our capacitor here, and we have our current I3 there. So kind of just drawing it out and going through it in your head sometimes helps a little bit, even though the other one's provided to you. So all the information that I have here, I have my I1, my I2, my I3, my voltages V1, V2, V3. I have my L1 and L2, my resistance R, and my C value here. And they want us to find a model for the currents, our I1 and I2, and for the voltage V3, given our input voltages V1 and our V2. So as with any of the other problems here, what we want to do is once we have all the information, our setup page created, is we want to figure out what key equations we're going to use to start solving this problem here. So what we can do is we can reference back to the table here, 7.2.1, so this is in your textbook and in the lecture slides as well. So this one here kind of relates from a fluid quantity over to electrical quantities over here, what the relationships are, our charge Q, our current I, voltage V, electrical resistance R, which R is equal to V over I, our electrical capacitance here, C, so C is equal to Q over V, and we have our electrical inductance L, where L is given by the relationship here, L is equal to V over di dt there. So my key equations here, I'm going to grab the ones out that I think I'm going to utilize for this problem here. I have my standard V is equal to IR. I have V, once I rearrange the last equation from the table there, V is equal to L times di dt, coming from rearranging this and solving for V. And I also have this relationship here that I of t is equal to C times dV dt. So these are my key equations I'm going to use for this problem here. I'm going to take the last relationship here. I'm going to solve it for C. When I solve for C, I see that C is equal to I dt dv. So if I solve this for my dv here, C dv is equal to I dt. Move the C back over the side, so the change in voltage is equal to 1 over C times I dt. So now I have a page of all my key equations that I'm going to utilize for solving this problem. So now that I have my setup page and all my key equations, I can begin my solution here. So what I want to do now is I bring over my circuit diagram here, and again, I just used the one that was given in the problem statement. It's a little bit neater than the one that I did by hand. So I'm going to reference back to this as I'm going through, and what I want to do is solve for my voltages. So the first thing I'm going to do is look for my V1 right here. So if I go for V1 first, I can see the V1 starts here, goes up through my R, through the current here, the inductor there, over to my V3 right there. So now I can write out my equation. So I have the first voltage here is my V1, my input voltage, V1. Then I have my RI. So V is equal to IR. So I have my second voltage, part of the voltage here is R1, I1, plus now I go through my I and my L1 over here. So I recall that equation from my previous slide there. This is L1 di1 dt plus my voltage 3 there. So this gives me equation that I'm going to label here as number 1 for V1. So now I can go from here, from my V3 over around this way like this to V2. So I draw that one out. So I have first voltage, my V3 is equal to, I have now this inductor here times my current there. So I have this L2 di2 dt plus V2 from this guy here. So I'm going to call this my equation number 2 here. And then last, I'm going to go through the leg here from my V3 voltage down through the capacitor here. There's my I3 right there. So my V3 is equal to, again, based off the equation from the previous slide, 1 over C I dt for that voltage there. So now I have all these relationships given here. So now what I can do is I can solve this last equation here for my I3. So I rearrange this a little bit. So I say that I3 is equal to now C dV3 over dt. And I recall now if I take a look through this, my I1 is equal to my I2 plus my I3 over here. So I have this relationship, I1 is equal to I2 plus I3. So I can plug in now to this relationship here. So I plug in my I1 is equal to I2 plus my I3, where my I3 is from this guy right here, this relationship here. So I can plug that in for my I3 there, bringing down to this equation that we now have down here, that I1 is equal to I2 plus C times d over dt of V3. So from here, we can go back to our equation 1. So I'm rewriting equation 1. Again, this is why it's great to label these as we're going through. So not only can you follow through your work, but the grader can, whoever else might be reading your problem, can understand where you're getting things from. So I rewrite out my equation 1 right here. Voltage 1 is equal to R1 I1 plus L1 times dI1 dt plus my V3. So that's my equation number 1. I'm going to rearrange this now a little bit, and I'm going to say now V1 is equal to V3 plus my R1 I1 plus my L1 dI1 dt. So that's just slightly rearranged. Then I can do my transformation here from my Laplace transformation. And when I do that out here, I end up with this relationship here. Now my V1 is my V1s. V3 now is my capital V3 of S. And now I have my R1 I1 right here, relationship of S there. And now I have this last part here, L1. Now we have here my di dt, so there's the s from that there, so there's the s there times capital I sub 1 of s there. So now what I can see is I can pull out my I1s right here, so I pull that out right here, rearrange this, and I have V1 of s is equal to V3 of s, plus now I pulled this out here, R1 plus L1s times here I1 of s. So this is now my equation there after the transform. So I'm going to do the same type of thing with my equation 2. So I rewrite out my equation 2 on this sheet here. You can reference back to my previous sheets of my solution as well. So I've labeled for my equation 2. Equation 2 is V3 is equal to L2 times my dI2 over dt plus my V2 value there. So now I can solve this. What I'm going to do is I'm going to solve this for a negative V2. You don't have to do the negative, you do a positive, but I'm going to do it for a negative V2 for our solution here. So negative V2 is equal to negative V3 times my L2 times d over dt of my I2 right there. So then I can do my transform on this as well. So this ends up being my V2 is now my negative capital V2 of S. Negative V3 is negative capital V3 S. Plus now, again, I have my d over dt first derivative there. So this is L1s times 9I, capital I2 of S there. So this is my next transform from my equation 2. Lastly, we do it for our equation 3 here. So equation 3 was this I1 is equal to I2 plus I3. We plugged in for our I3 right there. So now I can rearrange this and I say I1 minus I2 minus this relationship for I3, which is negative C times d over dt of V3 is equal to 0 there. Now I can do my transform of this guy here. I1, capital I1 of S, I2, negative I2 of S there, minus this right here. There's your d over dt. So there's your S value right there. So C times S times V3 of S there is equal to 0. So that's from our third equation there for our transform. So now what we have is we have 3 equations and 3 unknowns. And now this is where we could solve this by hand. It'll take quite a while, but it is possible, and get an equation for each of these as we rearrange and try to get all our V1s in one equation, all V2s in another, all V3s in a third equation, all alone, not dependent on each other. We can solve them simultaneously, plug in one for another, or we could plug these into MATLAB, Python, or another numeric solver. So we have those 3 equations there. We want to arrange them. Again, the problem it asks us to solve for I1, I2, and V3. So as we look through, we can see, okay, I need to get an I1 by itself completely. I need to get an I2 by itself completely, and I need to get a V3 by itself completely here. So you can solve these all simultaneously. I would suggest what you would do is plug this into a numeric solver, use MATLAB to solve them all, back out, again, your I1, your I2, and your V3. So you can see these are the answers here. And what you can note is the denominators are all the same in those. We could call these a DS for all of these and just separate out and say our DS is this right here, just to make the final answers look a little bit cleaner.